don't have any doubt? Anyone? Shall we go ahead? Chali, all right, good. So yesterday we just discussed about the category of protocols and what is the difference in on-chip protocol, peripheral protocol. Okay, and today we'll see in detail for that only. 1 second, let me hide this. Yes, Chali, all right. So you can refer that content which I already shared. What we'll cover with in that respect, you can consider that. Actually, all right. So here we'll start. Okay. So yeah, types. Or let's say um, yeah. So any protocol basics. So if you already done any protocol, so it will be easy. And if not, then also no need to worry. You will understand, right? So basically, the protocol is nothing but a guideline, okay, and which will help us to do a transfer or something, okay. So, but I want to put here the category, basically the types, okay. So protocols having basically mainly two categories. Okay, so two categories, and mainly we have one is that on chip. So on chip protocol, and another one we have is peripheral. Peripheral. So what is the main difference in this on chip protocol and peripheral protocol, and why this required? So let me just tell you here. Let's say you have your chipset. Okay, I'm taking two case. So you just want to transfer the data. In one case, you want to transfer within chip. Let's say this is your TX-RX, and in another case, this is your TX, and this is your RX. Okay, so basically, this is outside. This is not on chip. So now, what is the main difference in this? So the main difference in these two is whenever you are sending a data, so you have to connect them through clock, through TX, RX, address, data. So lots of signal require here. Let's say some address you will send, some data you will send, some ready signal you should send, some busy signal. I mean, lots of signals are there. You have to ensure whenever you are communicating. So if you are expecting in the similar way here also, if you are expecting in the similar way here also, let's say you have a address signal, you have clock signal, you have data signal, you have ready signal, you have a busy signal, you have error signal, and dot 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 dot. So let's say you are expecting a kind of 50 signal here, and you are expecting 50 signal here. So can someone tell me what's the problem in this case? Do we have any common problem in both the case or in any one case, or you are not seeing any problem in any case? Can someone tell me?
Maybe in the peripheral there is a clock difference.
Clock difference? Oh, okay. I'm not signal specific. Let's remove the clock. Then I'm asking if I will go in this way. So you see any challenge or any serious issue which will be as per user perspective or as per developer perspective, any serious issue you are seeing here? Because I am seeing a very serious issue. and let's try to understand, there is only no one tx rx. Let's say we have 10 tx and we have 10 rx. So similarly here also 10 tx and 10 rx. So it will be like that. Similarly for other 10 also, it will be address, data, and those signals. And here also we will have signals. So like that. So do you feel any problem is there? So that will only answer this question, why we have two category. Why we have two category, that itself will answer this question. If I will ask you why we have these two categories, how you will answer this question? We know we have two category, but why? Why not only one category? Anyone? No? Okay. Try to understand like that. Let's say this is your laptop, this is your PC, and this is your some memory. You know how you might have hard disk or something, or you might have your mobile phone or something. Basically, some memory is there, and you want to transfer data from your PC to your memory. So, and let's say in this case, we are having 50 signals or 50 signals. So 50 signal is nothing but 50 pins. Do you agree, guys?
Yes, sir.
Yeah. So if you are having 50 pin, okay. So how can you imagine, how can you connect a 50 pin laptop, oh sorry, a 50 pin pin, how can you connect between your laptop to mobile phone or any memory? You have memory card readers, you have hard disk. So how you'll connect them? So basically what happens, the pad will be of large size or it will be of a small size? Can you tell me, guys? The pad, whatever you need to connect, so what will be the size of that pad? Can someone tell me? No response.
It will increase based on the signals.
Based on the
Like
signal, but
signal
let's say here
increases.
we are taking 50 signals, right?
So we
So it will
need
be,
a big interconnect.
yeah. And if you saw in your laptop, you are having multiple ports, right? So let's say 4 or 5 ports for different purpose. Let's say 3 USB you have, and 2 C type, and more for that HDMI and those things. So if all those ports are having 50 pins, so what do you think? The laptop size or the pad size will drastically increase or not? Or will it
Yes,
be possible to
drastically
keep those
Area
increase.
ports?
area
Yeah.
increases, thereby power consumption also increases.
Forget about power. Forget about power. So power will come into picture when you will use them. So what about mobile phone? So because for this 50 pins, if you are having at the laptop port, so the same 50 pins should be available at your mobile phone also, right? Or you need some
Mm,
converter. Then you need a kind of adapter or converter kind of thing.
mm.
So you understood what is the main challenge here. If we are, yeah, but go to the second case. If you have TX and RX, and let's say there are 50 pins. So here I should not say 50 pins, these are 50 wires because they are internal. So if they are 50, if there are 100, so do you think there is any big issue with this? Don't consider for now power and those things. So don't consider chip area and those things. On
Yeah.
the top level we are discussing. So do you feel any issue in this?
Yeah.
Yeah. So you understood, guys, why there is a big issue whenever we are moving to the peripherals. So whenever we are moving to the peripherals, immediately we are limited by what? Immediately we are limited by what?
Yes.
Port connections.
Port
Port
connection
connections, you
pins.
can say whatever you can say, but I will say immediately we are limited by number of pins.
Pins.
Can you imagine if USB is having 100 pins? Can you imagine? Then how bigger a USB port will be there? It's possible. We are not saying it's possible. But then, can you imagine your device? If your mobile is having 100 pins of pad, So one side of mobile will be captured by that only. Then how you will add display? Then your mobile phone will become kind of a tablet size or laptop size, and laptop will become more bigger. And then we'll go for the higher speed. So don't know what happens. So you understood? Whenever we are limited by pins, so this is a one issue. Now let's say if I am inside chip or on chip, so then what happen? Then what happen? Although I will try to reduce the number of wires, but there is no such limitation. Such limitation means it's not like that if I am increasing 10 wires, it will become a big issue. But at the on chip, at the peripheral side, if I am increasing even a one pin, that will create a big issue for me, because hardwares are not possible to easily move or easily change, right? So here I don't have that issue. So now can someone tell me what is the still issue here, or you will be limited by what if you are in on chip? So definitely no, you will not limited by number of pins. Then you will be limited by what?
Space.
Huh?
Space consumption.
Space, those PD things I'm not considering as of now. I'm just talking about functional and performance. Oh, performance still is a power issue, but okay, let's support you. Okay, space. What is next? Space is definitely a issue, but is it that much of consideration? Answer is no. Or when I said we are limited, I mean we can't go in that way. So spaces we can go, because if you are increasing ten wires, how much space it will take? It will be negligible with respect to entire chip, because it have millions of gates and those things. If you are increasing 10, 20, so there is no effect, right? Yeah. Okay, let me ask in another way. We this TX RX is nothing but this is CPU and this is memory. Agree, guys? Do you agree? Both
Yes.
are both are on chip. So if
Yes.
you want to access something, or CPU want to access something, so can you imagine? Can you imagine? Let's say I give you freedom for all. I will give you freedom for power, for space, for wires. You can use any whatever you want. What you can use any whatever you want. And then if I will ask you, if I am asking 10 GB data transfer, or to access 10 GB data, so can you transfer this in 0 nanosecond?
No.
Can you transfer in this 1 nanosecond?
Complexity increase and
Ah,
time duration for
no. When I said you are free, you can increase any parameter. Let it be complex, let it be costly, let it be heating, let it be area. Consider everything. I am giving you flexibility for all parameters. Then also is it possible to do in 0 nanosecond? Tell me. So what mean by 0 nanosecond? 0 nanosecond
Not
means
possible.
infinite frequency. Infinite frequency means, so you listen or you heard, let's say i7 processor that work at 2.4 gigahertz, something like that you heard, and 4 gigahertz Snapdragon processor, something like that 3.4 gigahertz you heard.
Yes, sir.
So what is indirectly what indirectly I asked you, can I increase this frequency, or can I make a processor which can work up to infinite gigahertz frequency, or in not infinite, then can I say 1000 gigahertz of frequency? Can I have
No,
that much of processor? Huh?
no, no.
Yeah, why? The reason is
Since
why.
we are not using the supercomputers, we don't have in data centers. Maybe we can
No,
use
what's
that.
the challenge here? So here what we conclude, we are limited by frequency. So that is I conclude. We are limited by frequency. मतलब एक टाइम के बाद हमको फ्रीक्वेंसी से रुकना ही है. एंड इन पेरिफेरल्स एक टाइम के बाद हमको पिन से कंट्रोल करना ही है, अदरवाइज हार्डवेयर विल बिकम टू लार्ज, और जो कि यूज केस नहीं रहेगा. सो my question is how you can justify we are limited by frequency? How you can justify that? Anyone have any response, or shall I? Okay, no worries, let me tell you. So try to understand, guys. Try to understand like that. If we are having a processor and memory, so those are nothing but containing uh, registers. Agree? No response. And registers are nothing but flip-flops. Even memory is also a registers. No response. Flip-flop, I mean.
Yes.
Yeah. So let's try to understand, or let's assume we have 10,000 flops. We have 10,000 flops. Okay. So we have 10,000 of flop, and they're connected like that. And if I am, let's say, asynchronous or synchronous case, whatever you can take. So what is I have to ensure? I have to ensure here whatever outputs I am getting from this flop, and it is going to the next flop. It is going to the next flop. So till that time, my clock should not toggle. Else I will miss. That update. So I have to ensure, basically in the general term, setup and hold time. So setup and hold. So setup and hold time violation should not occur. That is the basic answer. But if you want to understand in detail, so this is the reason. You have to make available that output until next flop sampled or took that data. So because you can't go beyond that. You can't go. If there is no setup and hold violation, if there is no dependency there, believe me, you can go till infinite frequency. So protocol don't have a limitation. सर ये प्रोटोकॉल का लिमिटेशन नहीं होता है कि आपको इतने गीगाहर्ट्ज तक ही जा सकते हैं. प्रोटोकॉल्स आर मेड, you can use them theoretically up to infinite frequency. Either it's a AMBA protocol or any protocol, on chip protocol. So theoretically it's possible. So protocol can be used for infinite frequency also. But in the on chip, just because of these flops, you are limited by frequency. So that's why there is a else why they are putting 2.4 gigahertz, that much of accuracy. They can put
Excuse me.
some round of number like 10, like 20. So because this is the maximum possible. So and based upon that, setup and hold should not violate.
Sir, you are saying that there is no compatible device to handle this infinity frequency.
Yes. So sorry. See, what I'm saying is, protocol is one thing, and our RTL or the device is one thing. So when I said limited by frequency, it's not protocol who is limiting. Protocols can be used theoretically at infinite frequency itself, but at infinite frequency, that chip will not work. So this limited by frequency is also a limitation by chip itself, not by protocol. So because we are categorizing here protocols, So that's why I'm putting these things. You should not think like protocols are limited by frequency. Answer is no. Let's say if I will talk about AXI. So AXI can work if there is a device, okay, that can work till infinite frequency. You can transfer the data with AXI there also. And let's say in future, if this 2.4 gigahertz will increase to 100 gigahertz, at that time also you can apply the AXI protocol. So protocols are categorized based upon that, but they are not limited. I mean, the reason for that I told you. So the reason for this on-chip protocol, I mean that limitation is just because of the setup and hold, and for the peripherals which are limited by number of pins. So the reason for this is I mean the number of pins. If let's say you don't care about the number of pins at peripheral, so on-chip protocol can also be used at peripheral. So there is no limitation on the protocol side, but there is a purpose to achieve that. We are categorized like that, and we are using like that. Okay. So now how we can conclude here? So how we can conclude here? We have two categories. One is on-chip protocol, and one is peripheral protocol. So on-chip protocols such as AXI or let's say AHB, AXI, and PCI. Okay, so now they are limited. They are limited by frequency of operation. Okay, they are limited by frequency of operation. Now, but what about peripherals? What about peripherals? So peripherals protocols are limited by number of pins, such as, so if you'll come to the protocol which are peripheral, so such as USB, okay, and then PCIe, and then SATA, then SPI, okay, and then UART, etc. I mean, okay, UART also you can take, and then etc. So what about these? What about these? So they are limited by number of pins, number of pins. I mean, if so, what will the challenge in this protocol? Let's say USB. So if you want to make any enhancement in the USB, you can't increase the pin. Do whatever you want. So you have a different version of the USB. But did you hear or did you face any time they are increasing the pin? Answer is no. So because at the peripheral side, we are more curious about the number of pins. Okay, so this should be number of pins, not of pins. Okay, so number of pins. Yeah. So now, how data communication is happening in this? So in terms of transactions, so here data transfer, data. So data transfer happen in terms of transaction transactions. Okay, and while in the peripheral in terms of packets or frames, in terms of packets and frames. Fine. Yeah. Any other difference? I mean, we have lots of difference, but on top level only we are discussing. Okay. So one more thing we can add here. So in this on-chip protocol, we have dedicated, I mean, handshaking. Handshaking happen using dedicated signal. Dedicated signal means for a handshaking purpose, we have a few signals. Those can be used only for handshaking purpose. Okay. So, and in this peripherals, we don't have. So can someone tell me why don't we have? Can someone tell me?
Inside packet itself, We have acknowledge and
No, you are telling how handshaking we are doing. But my question is, why don't we have? What's the issue? If we will have handshaking signals, if we have
pins, more pins.
exactly. So the intention is to reduce the pins. We are limited,
Yeah.
and in the on chip we don't care. वहां पर हमारा सारा इंटेंशन फ्रीक्वेंसी के लिए है, यहाँ पर हमारा सारा इंटेंशन पिंस के लिए है. Okay, so we don't have that dedicated handshaking signals. Yeah.
Sir, what
Yes.
is the difference between transaction and packet?
Transaction and packet means, so transaction, when you say transaction, so it should be like first address phase, then data phase, then response phase, like that. But packet and this means there is no phase. The packet itself contain the header, the payload, the error, I mean CRC. So it's a packet, and this is a transaction. Like first address phase will happen, will then data phase will happen, then response phase will happen. It's like that. So here the packet we are sending, the packet have that much of information, and the reason behind it is because here we have dedicated handshaking signals, but here we don't have handshaking signals. So for that purpose we are sending the packet. Okay. Yeah. So now if we'll go ahead, so what are the advantage and disadvantage you feel in the on chip and peripherals? Then I will go ahead and in the similar way we'll discuss what is the difference in parallel and serial, and then we'll move for the serial, and then followed by we'll go for the PCIe, then PCIe. So like that we are targeting. Yeah. And
In the
also if
peripheral, we are having peripherals we can remove or use again. But in the on chip, it is already fabricated, so we cannot remove from that.
what we can remove?
Any peripheral, if we are connected to our device, just like if our mouse is connected
No,
to laptop, it can be
but
removed.
here we are discussing about the protocols.
Okay.
So protocols means how we are transferring the data. So in terms of that, what are the advantage, what are the disadvantage?
Okay.
So that's not a advantage, that's a device use case, whatever you are telling. So peripherals mean for that. It's not like there is an option and we are opting in that, and we are not opting in that. So
Speed
think
is the
like that.
limitation.
Yeah. So it's and also how you can select a protocol, or how you can differentiate the protocol. So protocol selection or the differentiation, how you can find out. So I mean, either you can have performance a one parameter, which you can say bandwidth also. Okay, so basically what I'm saying is, if let's say you are asking for the high performance, so you can find out which protocol is best suitable to you. Then it could be power, it could be that pin 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 you can say, or size you can say, or cost you can say. So these are the parameter, based on you can find out like which is suitable to you. Why it is not going? Okay. Yeah, fine. Yeah, chali, all right. So now we'll go ahead. Oh, I should use this here. Yes. Yeah. So now on chip protocols, what are the advantages on the on chip protocol? Then we'll go for the peripherals. Okay. So on chip protocol. So what are the advantages? We have lots of advantage. It's not like that we don't have advantage, and we have some drawbacks also. So what are the advantage we have? Let's say, so advantage we have is, So all signals, I mean multiple signals, or we can say all signals, signals.
No limitation on pins. That is
Okay, yeah, that's also advantage, but yeah, you can put, but that is
All
you are
signals were parallelly driven.
yeah, that exactly that I'm trying to write here. So all signal communication, okay, all signal communication can be concurrently done. Okay, so concurrently or the parallel is not the appropriate word. Concurrently you can put like at the same clock. You mean parallel also you can use. Okay, yeah, and all signal means, let's say we have AW address, and we have AW bus, okay, and we have AW size. So in the address space we are sending these signals and etc. So those signals can be driven at one clock itself, at one clock, at one clock itself. So one more advantage is we are having handshaking. Okay, we are having handshaking, and so handshaking is also one advantage, and one more advantage is we can do multiple. I mean, it supports multiple types of transfer also. Multiple types of transfer means some overlapping, out of order, etc. I mean, this type of transfer is also supported by this. Okay, on chip protocol. Now I'm not interested in advantage. I'm interested in the some drawbacks. Okay, so some drawbacks. So what are the major drawbacks? And from there I will go to on chip. Oh, sorry, peripherals. So can someone tell me what are the major drawbacks you feel? Yeah. So what are the major drawbacks you feel on this? So first is limited by,
frequency.
yeah, limited by frequency. Okay, and now you can put that example which I gave to you. So let's say some processor. So generally processors are limited by, or are work at approximately 2.5 gigahertz. Okay, so 2.5 gigahertz. Okay, and yeah, yeah, fine. So now can someone tell me something different? We can put other drawbacks also, but I want to pull here. We have that disadvantage, that is skew. Skew. Okay. Now, what is this skew? Do someone know what this skew?
Phase difference between two clock.
What difference?
There were two things: positive skew and negative skew. The clock transition throughout the all flip-flops will be different from one to other. Since we are using the synchronous domain also, due to skew, the flip-flops will get the clock uh, later on time.
Okay. So, what is the general? I mean, forget about clock. In general, let's say you have signal A, B, C. So, what mean by skew in with respect to that A, B, C? Forget about synchronous, asynchronous, clock, data, address. Forget about everything. We have three signal A, B, C. We have TX, RX. When can you say the skew introduced, or what could be the reason for that? That's my question.
Delay.
Delay. Yeah, now you are right. Now you are right. So, what kind of delay you are talking here?
From uh, from transmitter to receiver.
Okay. Yeah, yeah. You are more close. Others, any input here? So, let's say you are having So this is some TX and this is some RX. So as we mentioned, we are not limited by wires. So we can have multiple wires, and because they are on chip, so we have to do floor planning also. And floor planning requires some planning, definitely. So where we are putting these wires, definitely we need to opt some path. So let's consider there are three signal A, B, C, or S1, S2, S3. Signal 1, signal 2, signal 3. So this is signal 1, S1, and this is signal 2. So definitely they can't overlap, right? This is signal 2. And let's say this is signal 3. This is signal 3. So if you will see at higher level or at top level, you don't see any issue with this. But if we are at very high clock, can you imagine a 2.5 gigahertz? So at very high clock, so time is become, I mean, higher frequency means very less time. High frequency means very less time. Very high frequency means very less time. So if frequency is in gigahertz, so equivalently our time will be considered in nanoseconds. So what could be the problem here? Because all wires can't be of same size. It's not possible to all wires will be of same size, because we are doing this floor planning. So definitely we have to set them. We can't overlap them. So you can see if you are making connection from this TX to RX, so this wire will take time T1 and this wire will take time T2 and this will take T3, right? So let's say at the same time, if you are putting something from this TX side, from this TX side, from this TX side, so can someone tell me at the RX side when to sample? When you should sample?
After T3. Since
When
T1 is not
you,
equal to T2, T2 is
yeah,
not equal to
exactly.
T3.
So when you should sample, you should sample at the correct time. And correct time is not T1, not T2, T3. So basically the slowest thread will decide the actual time. Else what happen? Let's say T1 data is here and this is here and this is here. And if and at the last time T1 reached, then T2 here and T3 here. And if you sample, so you may sample wrong data. Okay, so this is nothing but skew. Now skew can be categorized into two. If the signal, let's say S1 is the clock and S2 S3 is a data, so it's all about signal, right? So if it's a clock, so we can say it's a clock skew. But if it is a data, we can say it's a data skew. It's very simple, right? So skew can be of two types, clock and data, but the concept is same. So because we are in the on chip and we have a huge number of wires, hence skew is the one problem. Agree, guys? No response?
Yes, sir.
Yeah. Now why we are discussing this here, sir? पहले तो ऑन चिप क्यों डिस्कस कर रहे हैं, फिर स्क्यू क्यों डिस्कस कर रहे हैं? Because this problem should not be there in peripheral or in PCI, or how it handled, that we will discuss. So before that you should know this. Clear है? चलिए, all right. So skew is one problem, and skew can be of two type, which is clock and data. So clock and data. So skew is always I mean, it's a bad thing. Okay. So now we'll see if I want to summarize here. Skew. So what is actually skew? So signals arriving on different lanes of same port with wiring delays is nothing but will introduce skew. Okay, now why it happens? Because all signals between you can say master slave, you can say TX RX. So between TX RX are wires. Okay,
So
and
different
these,
length.
yeah, so no, length is, I mean, first we are discussing wire, and these wires can have delay means sometimes so okay, let me tell you, actually this is on very top level I introduce skew. अगर आप इसकी स्टडी करते हैं, so skew may introduce with different region. So length is one region, I mean length is one region, so it may happen due to other regions also. So what is the correct word here? We will just say it's a delay. डिले का एक रीजन लेंथ हो सकता है, और भी रीजन्स हो सकते हैं. ओके, so when can we say it's a skew? If there is a delay introduced in different wires, that's all. So these wires can have varying delay. So did anyone heard about this skew before this earlier? आपको पता है इसके बहुत सारे वो सॉल्यूशंस भी हैं, हाउ वी कैन
Yes, sir, we
reduce,
know. In
how
the
we can
STA,
reduce.
we know.
Oh, what you're saying?
In static timing analysis, we know about
Yeah, so there we have a tree, we can use
yes,
tree,
sir.
we can use star. So I mean length is a one
I
factor. Yes.
I
So
network, star network, those networks we need to reduce it.
करेक्ट. तो हम वो डिस्कस नहीं कर रहे हैं, बट वी आर जस्ट टेकिंग कि इसको मतलब डिले एक प्रॉब्लम है. वो तो अगर आपको नहीं आइडिया है, दैट्स व्हाई आई एम गिविंग यू बेसिक आइडिया. लाइक इफ देयर इज ए length difference, then it may introduce skew, so that you can understand easily, right? So now skew is a concern or a problem, concern in parallel. So in parallel, all the parallel communication. Why? Because in the parallel communications we have lots of wires. That's why it will come into picture. So communication protocol. Yeah. So that's why it will come into picture. Okay. So why? Since all signals driven parallelly. Right? So now what happened here? Skew. So we have two types. So one is data skew and another one is clock skew. Okay. So what about data skew? Wiring delay. I mean, what I want to say here, if delay in data is nothing but data skew. So let me put varying difference of arrival time in data bits of of signal is nothing but that data skew. And what about clock? So we can say wiring difference of arrival time in different ports with, I mean, with respect to with respect to clock edge. So if with respect to clock edge we are getting, so we'll say it should be ports. Ports. Yeah, fine. Yeah. So now we'll go ahead and we'll see how this problem is not there, or how about peripheral protocol. Okay. So let me take this. Oh, this is on chip. Yeah. This I have to go. Yeah. So now we'll go ahead and we'll see what about peripheral protocol. Yeah. So what about peripheral protocol? So can someone tell me the advantage of peripheral protocol? And we'll see some drawback also. Okay. And before that, let me write at least one line. Yeah. So when to say these are peripheral protocols, or when we'll take consideration of this peripheral protocols, let's say if you want to transfer the data, or data transfer happens at chip boundary. Okay, at chip boundary. So that's all. So here, as I already mentioned, they are limited by number of ports. So we can also mention we need minimal number of wires. Those are nothing but ports here. I mean wires, but those are nothing but ports here, because wires are internal. Okay, ports. So yeah, that's all. That's all. Okay. So for example, we can put, for example, USB. USB has only 4 wires, which are nothing but port. So we have only 4 ports at the USB. So can you imagine if USB is having 200 wires or 100? Answer is no. Okay. So now what are the advantage of this? So advantage of this is definitely, so because we need a uh, smaller number of pins, right? A smaller number of pins. So that reduce port size, which is good, right? Which is good, and definitely which is having limited number of. Yeah. So what could be others? So this is the very I mean, main advantage of this is it can work at even I should say very, okay, very high frequencies. Now, now, so now you should think, why it can work at very high frequencies. So anyone want to add something here? How it can work, or how it is different, or what is the main key thing which we are using here to achieve very high frequency? Why I'm putting this word here? Because if you'll go to on-chip protocol, so here I mentioned in the drawback, we are limited by frequency. But here I am writing, it can work at very high frequency. So how can someone tell me? So what was the reason for not achieving very high frequency? You remember in this on chip I mentioned, so if we are limited by frequency, the reason was clock means that setup and hold time. And when I said it can work at very high, so definitely there is no issue, of setup and hold time, right? Then only we can say. So what do you think? How we achieved this? How we achieved that? What do you think? Can someone tell me? You want to add something here? And another देखिए, हम ऑन चिप से अगर पैरेलल की बात कर रहे हैं, तो इसका जो ड्रॉबैक है वो हमारा रिजॉल्व होना चाहिए. फॉर एग्जाम्पल, द मेन ड्रॉबैक्स आर लिमिटेड बाय फ्रीक्वेंसी एंड अनदर ड्रॉबैक इज स्क्यू. So those all drawbacks will be resolved or will not be there in peripheral protocol. But you have to tell me how you think. Or let me ask in different way. What do you think? How can we overcome these two issues?
Excuse me, sir.
Yeah.
Uh, Anyways, we are going to store in the flip-flop, the register itself. So definitely we are going with the set up our whole time violation if there is a mismatch occurs and the speed maybe increases.
Okay, so you are saying this problem will be still there in peripheral protocol.
I'm not saying like that, sir. How we will do that thing?
That's my question.
Anyways, we are going to store in the register itself.
Yeah, that's my question. You are right. We will store.
Okay,
But that's
sir.
my question. How we can...
Here the limitation was clock. So yeah,
No clock?
there is no clock. That's what I'm thinking.
In peripheral protocol, there is no clock.
It should be there, sir, since we need to store in the register.
No. Okay. Tell me. I will ask.
Synchronize with respect to single clock signal.
Single clock.
All things are connected in serially. That
So serially connected. Then what happened?
then skew can be avoided.
But we are talking about here first how we can achieve very high frequency. How setup and hold violation will not occur. That's my question. No? First. So setup and hold violation, how it will not occur. So some of you are very close, but I want the crisp and correct answer. It seems you heard something or you read few lines from somewhere and you are putting here, but you don't know the actual concept. So that impression I get. But if it's not like that, then please go ahead and please tell me exactly. Anyone? Last chance? Some of you were close, but didn't get exact answer. Can someone tell me last chance?
Sir, we can store in the cache like memory, and then we can store in the original thing. Like the transfer happens.
Any memory is a flop only, right?
Oh, yes, sir, flop only.
So then if clock is there, definitely setup and hold violation will occur, definitely. Because if clock is there, if flop is there, definitely they have some internal delay.
Okay, sir. In order to avoid that thing, we can store that thing in your FIFO like.
Oh, FIFO, what's FIFO then? FIFO is also a memory, right?
Yes, sir. That one is also a memory.
Yeah.
Then how can we achieve this thing?
That's my question. So the only way is, let's say if to avoid setup and, or let's say, or setup or hold violation. Haji, what's the way to avoid setup and hold violation? We have to avoid clock. That's the only way. So now can someone tell me how we can avoid the clock and how we can use the clock?
Flip-flop will work on the clock only.
Huh?
But the flip-flop is going to work on the clock itself.
That's my question.
We must and should need to have the clock.
Yeah, that's my question then. Then how we can achieve? See, To get high frequency, we have to avoid setup and hold violation. And to avoid that, we have to avoid clock. तो क्लॉक ही हटा देंगे तो फिर फ्रीक्वेंसी कहाँ से आएगी सर? So that's my question. So here the thing is, one second. Are you getting my point? Yes. One second, guys. Why I'm not getting that option? Yeah, okay, I'm getting now. Okay, so we have this TX and we have this RX, fine. And what I was saying, so let's say if this is a clock signal, this is a clock signal, and these are other signal. Let's say address and data, and some BG error signal, right? So now what happen is, if clock is there, definitely it will introduce, or we need to take care, set up or hold a violation thing. And if you want to avoid that, then you have to avoid the clock. And if you avoid the clock, then there is no meaning of saying high frequency, because frequency is nothing but a clock frequency. So then how can we achieve that thing? It's a very interesting thing. And this is the first thing which you should know about PCIe. Sorry. Can someone tell me now? So definitely we should do something like that. Clock we are using, but we are not transferring. It's a hint. So what we can do, we can remove clock from this channel, and we can have clock here and we can have clock here. Make sense? But will it work? Answer is no. Why? Because they are two different clock. And if you are talking about very high frequency, so very high frequency means this should be a single clock, or this should be single clock. Else no synchronization will happen and data will shuffle. कहीं का data कहीं चला जाएगा sir.
CDC issues will occur.
Correct. Then what to do?
You can use the bird generator,
What?
body generator.
Baud rate. Baud rate.
Yes.
बॉड रेट तो हम एरर करेक्शन के लिए यूज करते हैं बॉड रेट, और वो तो तब करते हैं ना अगर हम कुछ पैटर्न सेंड कर रहे हैं. बॉड रेट आई थिंक इससे तो कुछ रिलेटेड ही नहीं है. सो ओके, और टेल मी हाउ बॉड रेट विल हेल्प इन दिस. ओके, टेल मी लाइक दैट. So anyone have any answer? Okay, someone commented. Let's see. We can mix clock and data. Wow. Okay, so Chirag, how we can mix, or if we will mix, then don't you believe we are losing data also? How we can mix? So others are agree with this word, clock and data mix.
No, sir.
No, sir.
Okay, so then what can we do? No answer. So anyone is aware of that AM/PM amplitude modulation and those things?
Yes, sir, I know.
So in that we have that carrier and that modulation we are doing on those things, right?
Yes.
Yes, sir.
Okay, yeah. So don't pull that concept here. Whatever I will explain now, that I want to tell you. Don't keep that thing in your mind. I'm going to explain something, but don't keep this thing in your mind. Okay, forget about this concept. Yeah. Now let me tell you. So actually, whatever he commented, maybe he know the concept, but he know on the top level. So he's not able to put the correct word, or a little bit he's correct basically. So clock and data mix, but mix is not the appropriate word. Okay, let me tell you how it's possible or how we are doing actually. See, try to understand. In peripheral protocol, we don't have such signal address, data, ye, wo. We only have limited, even very limited. Let's assume we have only TX and RX pin. Let's assume only we have these two signals. This is TX and this is RX. And for this is RX and this is TX. We don't have any kind of other pins, because in the USB also we have very limited, right? Can someone tell me what are those in the USB VDD and ground and then plus minus, right? I mean the TXRX. So like that we have very limited, correct? So we are very limited. We don't have address, channel, ye, wo, clock. We don't have. Then why? Then why? Then I mean not why. Then how we are using the clock? Or if I will talk about PCIe, PCIe is a peripheral protocol. So how we are using, or how we are making sure we are getting very high frequency by avoiding setup and hold violation. And that is possible only by avoiding clock. That's correct. So here I completely avoid clock. You cannot see a clock signal or a clock pin at the channel. So this is the transfer channel. This is the transfer channel or interface. Here you can't see there is no clock. No clock. Sir, I am leaving the session. Why? If there is no clock, then how we can make a transfer? I will tell you. Please stay here. So try to understand, guys. Try to understand, guys. This is some host, and this is a device. So as they are working at very high speed, so they generate their own clock. Let's say this is clock TX, CTX, or let's say this is clock 1, and which is, let's say, 5 gigahertz. And this will also generate a clock at 5 gigahertz, and then easily they can work. You got my point? So is this the solution or not, or still you have some problem? So let's say if I will fix the
Okay.
clock frequency. One sec.
The transfer domain and the receiver domain independently generate the clock with the same frequency.
Yes. So it's possible, right, to generate a same frequency clock. It's possible or not?
Yes, sir. But how the receiver domain knows whether the transmitter domain using only this type of frequency, like 5 gigahertz of frequency? How the receiver domain knows?
So that we can transfer with TX, right? Let's say let's say I will send this 5101.
Okay.
I mean, to answer your question, I'm telling it's not like that, but to answer your question,
Yeah, that's also possible.
then it's possible.
Yes.
Okay, so now can I say clock 1 and clock 2 are same clock? Now can we say if both are of 5 gigahertz?
Yes, sir.
What about others? See, I'm asking a very good question here. If clock 1 is of 5 gigahertz exactly, and clock 2 is also 5 gigahertz clock frequency, can we say both clock are same? Forget about protocol, forget about everything. Just a direct question. If I have two clock 1 and
Yes.
clock, yeah.
Yes.
What about others?
Yes, sir.
What about others? Answer is strictly no.
The phase difference is of this here.
Hmm. So they are not same clock. They are same frequency clock. सर सेम क्लॉक कहो, सेम फ्रीक्वेंसी क्लॉक कहो, बात तो सेम ही है. आंसर इज नो. सेम क्लॉक मीन्स सेम with respect to all parameters, and same frequency means only frequency is same, other parameters may vary. सर एक ही तो पैरामीटर होता है क्लॉक में. आंसर इज नो. देयर आर टू पैरामीटर्स. one is frequency, one is phase, and these together make a clock. So, sir, I won't believe this. Okay, so I am giving you two clock. Let's say one is this clock, and another one is this clock. So both are having same frequency, but are they same? Answer is no, because what happened? Because they are having phase difference. Can you see? Their pauses are not matching. So are they same clock or are only frequency same? Only frequency same, right?
Yes, sir.
Yes. So now let me summarize, and to answer, I should answer your question from where we started. So what happened, guys? What happened? How to achieve this? 1 second. Yeah. So actually what happened? To avoid setup or hold violation, we have to avoid the clock. That's correct. So we are not transferring clock over pins. There is no dedicated pin for clock. Then how we are transferring? So since clock is embedded into data pattern. There is no question of, or you can say here, which means there is no clock transfer over pin, or there is no dedicated clock signal. Okay, so basically we are avoiding transferring of the clock. Okay, so if we are avoiding transferring of clock, so there is no question of setup or hold violations. Hence it can theoretically work at infinite, but let me write, it can work at any speed. That means It's not limited by frequency now. It's not limited by frequency. Now I will explain. Please hold on. Okay. So now what mean by clock is embedded into data pattern? Because if someone commented clock and data mix, so how this statement and this statement is different? Let me tell you. First of all, try to understand here. I did not say into data signal. I said into data pattern, and it's not mixed, it's embedded. So how this statement is different from that statement? Let me explain you. And let me also tell you how actually it is happening. So try to understand, guys. In the PCIe, what happens is at the TX and RX, one second. Yeah. So here what happened? We have a PLL. We have PLL. Okay. And let's say this is RX side. So if we are working, let's say PCIe Gen 4, we are working. So for Gen 4, there is a dedicated frequency. For example, let's say 5 gigahertz. I mean, it's a very high, which is in actual, but it's a hypothetical. Let's say I'm taking 5 gigahertz for Gen 4. So TXR and RX both are aware for this 5 gigahertz signal, for this 5 gigahertz frequency. And there are clock generator which will generate 5 gigahertz frequency here. And here also, at the TX side also, clock generator is there which will generate 5 gigahertz frequency. Now what happens, as you are having only TX and RX, you are having only TX and only RX. You are having only TX and only RX. And TX and RX are used for sending data, only. So here, are we having dedicated pins for clock? Answer is no. So we are not transferring the clocks, okay? But if we are having different two clocks, how we can make them single clock? So what happens? The PLL what will do? So it will lock the phase. So phase lock loop is the full form. Okay, it will lock the phase. And how it will lock the phase? Basically, there are two parameters for clock to become those clock as a single clock. One is frequency and one is phase. So frequency is already same and phase has to be same. Same phase means phase difference should be zero. Same phase means same phase difference should be zero. मतलब अगर एक clock ये है दूसरा clock भी same होना चाहिए, like that. And this is the job of this PLL. And how this PLL will do this job? I mean, how this PLL will ensure there is no phase? So whatever data we are transferring, that data pattern. So data definitely, because it's a single pin, so the transition will happen. So sometimes there is no transition, but definitely a pointer after a point, the transition will happen. Let's say here there is no transition, but definitely there is a transition. So when transition happen, so this PLL is a superior block and it's a very complex block. Don't think like it's a simple block and how it can do. It's a very complex block, and that's the job of a PLL, to do phase difference zero. If you will simply put what's this PLL, you will get to know. Okay. So even if you'll simply write here PLL. So PLL uh, in communication, or whatever you can, yeah, in communication. So you will get to know it have this loop filter and CPU. I mean, it's a very complex block. Don't think. Okay, so phase log loop a feedback control system that synchronizes locally generated oscillator that will with a reference input clock, ensuring that maintaining the same frequency and the constant phase difference. So constant phase difference is nothing but, it's a zero phase difference with respect to actual. Okay, so it's a very complex block. Don't think it's a very simply, I'm just saying, okay, PLL is getting, okay, it's a vast, but it will ensure, there is no phase difference. And I mean, what will be the helpful to this PLL? Only data pattern. So what is the hint for PLL to get phase difference 0? That is nothing but data pattern. So that's why I kept this word here. The clock is embedded into data pattern. अब कितना भी तेज आप डेटा भेज लीजिए, okay, so because clock phase itself will be taken by that data pattern only, so you can send data at any frequency. Okay, so that is one thing. Now we'll go for next thing. That's a skew. That's a skew. So here in the skew, as we are not transferring, I mean clock skew. So do you think clock skew will be a problem? So clock skew will not be a problem. Can someone tell me why? जब सर क्लॉक आप भेज ही नहीं रहे तो क्लॉक स्क्यू कैसे प्रॉब्लम हो सकती है? सो क्लॉक स्क्यू विल नॉट बी ए प्रॉब्लम since clock is not having a dedicated port or clock is embedded. So clock is already embedded. You got my point? So clock के लिए जब कोई वायर ही नहीं है सेपरेटली तो क्लॉक स्क्यू आएगा ही नहीं. You got my point? So embedded into data pattern. Now we'll see. Something I have to tell. Let me think now later. Okay. Let me talk about that data noise. Data noise. In detail, I will discuss later, but in one line, let me tell you. So can someone tell me how that is taken care here? Can someone tell me? Specifically in the PCI? Anyone know? So because everything is dependent on data. So data should not have any error, right? Or any noise. Can someone tell me how to achieve that? No response?
Error correction.
हाँ जी,
Error correction.
एरर करेक्शन. सर इतना तो यहाँ सिग्नल है ही नहीं ना कि आप एरर पैटर्न भेजें, एरर डिटेक्शन भेजें. और मान के चलते हैं आपने एरर पैटर्न कुछ भी लगा दिया बिकॉज इट्स ए सिंगल पिन. तो सिंगल पिन पर 0 का 1 अगर हो गया तो आप उसको कैसे डिटेक्ट करेंगे? लेट्स से सम पावर फ्लक्चुएशन इज देयर, बिकॉज एक बिट भी आपका प्लस माइनस नहीं होना चाहिए. इट शुड हैव 100% एक्यूरेसी because you are dealing at very high frequency and you are transferring all data with single pin. Can you imagine you are transferring data at 1 TB speed, 1 TB per second, और केवल सिंगल पिन है TX? Can you imagine?
Also.
But and it's the real speed which are supported by this PCI. So how can you ensure that much of accuracy? Tell me. Others? हाँ जी सर बताइए. And it's very simple. So in detail, I will tell you later. But for now, let me tell you, you know how simply this taken care. We are sending TX with 2 pins or with 2 wires. One is TX plus and one is TX minus. सर नहीं समझ में आया. TX plus और TX minus का मतलब है these are voltage only. So let's say TX, if you are using 5 for 1 and 0 volt for 0. So there are way, let's say if you are sending for 1 you are sending 5 volt and for 0 you are sending 0 volt, and by some fluctuation, let's say this 5 will reduce to 2.3 volt, then at the receiving side it will become 0, and let's say this 0 will become 3.3, so this will be considered as 1. Agree guys? No
Yes,
response?
sir. Yes, sir.
Yes.
Yeah. So now how smartly it's tackled, okay, instead of this, can I take any one instead of this? I mean, instead of 0 or 1, can I take any one? So you want 1 or you want 0? Can I take 1
Okay, sir. One.
or you want 0? Okay, let me take 1. Okay, I mean, it will be easy to compare. Now try to understand what I'm saying. This is only with the TX. Let's say if I am transferring this same data with the TX plus and TX minus. Okay, now you tell me, if 5 is becoming 2.3, so the reason for that means something due to power fluctuation or something minus 2.7 occur to this wire. Do you agree? अगर 5 को 2.3 होना है तो नेगेटिव ऑफ 2.7 आने के साथ ही हो सकता है ना. If 5 is becoming 2.3, what's the only possibility? So due to power fluctuation, due to noise, due to some superimpose, minus 2.7 came. Agree guys?
Yes, sir. 0 is the only option.
हाँ, 0? नहीं, 2.3 से 0 नहीं हुआ. 2.3 को तो 0 आप इसलिए कंसिडर करते हैं ना, बिकॉज इट्स बिलो 2.5.
Yes, sir. Yes, sir. If it is
Yeah.
minus 2.7, then also it is 0 only.
No, I'm not going to that concept. See, here, this is what I'm saying is, the received is 2.3. Now this is approximated to 0 volt. I mean, receiver side, this is 0 volt. But how 5 is becoming 2.3? So if some superimpose is happening for minus 2.7 volt, do you agree with this or not?
Yes, sir.
Yeah. So now if you are transferring the same data with the two wires, let's say this is wire 1 or wire 2. So what do you believe? The same impact will happen on the single wire or both wire? It should happen with both wire, right? Okay. And now if you are transferring here 5 volt, and now you are transferring here 5 volt, so you will get 2.3 volt, 2.3 volt and 0 volt and 0 volt. I mean, it's a 0. It's a 0. So there is no advantage if you are transferring the same data 2 times.
Sir,
I mean,
but
agar
here,
wait, hold on. If you are transferring same value with the 2 times, then also there is no meaning of increasing accuracy. But if you will do something tricky here, so you are transferring TX plus and TX minus. Now let me tell you what is this TX plus and what is this TX minus. So TX plus and TX minus is nothing but, you are let's say if your TX plus is 5 volt, so what you are saying, your TX minus is minus of TX plus. I mean, whatever is the TX plus, that it's a minus of TX plus. So here what I will do, I will just say this is 5 volt and this is minus 5 volt. So TX minus is nothing but a negative version of TX plus, whatever it is. मतलब सेम 0 के केस में भी अप्लाई होगा, सेम 5 वोल्ट के केस में भी अप्लाई होगा, जस्ट एट माइनस. Now what happened guys? Or let's say if you want to add waveform, so it looks like this. This is 5 volt and this is minus 5 volt. Now what happened? You are getting this minus 2.7 volt on the both wires. So what will be the impact, or what will be the final output here guys? So for the first one it will be uh, uh, okay, one second. So let me take first a fresh example. I mean, there is no superimpose. So if you are transferring 5 volt and minus 5 volt, so how you will calculate the final output? So you should do tx plus minus of tx minus divided by 2. So in this case, it will become 5 minus of minus 5 divided by 2 will become 10 divided by 2. It will become 5, and which will considered as 1. I mean, this is the no superimpose or no noise case. Now here what happened? So this will become definitely 2.3. So what this will become, guys? So minus 5 minus of 2.7, it will become minus of 7.7 volt. Agree? So instead of 2.3, you will get minus of 7.7 volt. Now, if you want to calculate the actual value, how you will do tx plus minus of tx minus divide by 2. So it will become 2.3 minus of 2.3 minus of, or let me remove this. I will take directly this number. So minus of minus 5 minus of 2.7. Okay, divide by 2. So this will become 2.3 minus, I mean plus 5 minus of 2.7 divided by 2. Oh, sorry, plus divided by 2. So what value this will become? So this will become 10 by 2, and this will become 5 itself. That is, it will be the exactly same value irrespective of any noise, anything. So what I want to say here, let's say if you are getting 5, and if you are having minus 5, and you are getting 5 plus x minus 5 plus x, so you have to subtract 5 plus x minus of minus 5 plus x divided by 2. So it will become 5 plus x plus 5 minus x divided by 2. So it will become 10 plus x minus x divided by 2. It will become 5 of plus x and minus x. So this plus x and minus x is nothing but this 2.7. So definitely every time this noise itself cancel the noise. I mean, noise खुद को खुद से हमेशा subtract करेगा, और you will get a perfect signal, perfect with zero error, irrespective of any value of x. You got my point? No response?
Yes, sir.
Yes, sir.
Yeah. So why can you imagine, guys? सारी लड़ाई यहां पर हमारी नंबर ऑफ पिंस की थी. वी आर लिमिटेड बाय नंबर ऑफ पिंस, दैट्स द मेन गोल. और हमने पिन को 2 से 4 कर दिया. आई मीन वी जस्ट डबल द नंबर ऑफ पिंस फ्रॉम 2 to 4. Instead of tx rx, we are making tx plus minus and rx plus minus. That means you increase the pin by 100%. You doubled. But you know, just by double that, you are getting 100% accuracy. 100% accuracy. Is it or not? Because वो हर बार x minus x हो जाएगा, x कुछ भी हो. So why it is important? Because everything, मतलब आपकी क्लॉक की डिपेंडेंसी ही अगर डेटा पैटर्न पर है, so you can't expect even a single bit error in this data pattern. So for that purpose, you are transferring tx plus minus and rx plus minus. You got my point?
Yes,
So in
sir.
detail, we'll discuss this later. But as of now, so clock is not an issue because clock is not there. And data noise, how we improve that or how we reduce that? Just we are transferring tx plus minus and rx plus minus. So now what are the drawbacks? ये तो सब अच्छी बातें होगी sir. What are the drawbacks? So can someone tell me? So PCIe and DDR etc. Actually, these are, or these protocol are very complex. That means these protocol require complex pi circuit. मतलब बस इसका ड्रॉबैक यही है कि बहुत कॉम्प्लेक्स है, बहुत ज्यादा कॉस्ट है. सो दैट इज द only disadvantage, that is which increase the chip complexity and cost. So if you are not you are not curious about the cost, or if you don't care about the cost, then please go ahead. There is no disadvantage in this. So let me bold this. So these are the peripheral protocols. These are the issue, which was the issue in this on-chip protocol. And here we discussed the advantage and disadvantage. So you understood limited by frequency and the skew, how we resolve this, or how this is not in our peripheral protocols, right? So now anyone have any doubt up to here, please ask. Now I will go ahead and we'll discuss similarly, like we compared on-chip and peripheral protocols. Similarly, we'll compare and we'll go ahead for the serial and parallel protocols. So how they are differ, what is the necessity, how what are the advantage, what are the disadvantage, and those things. Then we'll go ahead. हाँ जी सर. So are you able to understand or no? हाँ जी सर, कैसा चल रहा है?
Understandable.
Okay, yeah. Okay, so shall we go ahead, or you have any question? So I will slightly introduce that parallel and serial protocols. Shall we start tomorrow? Shall I go ahead?
Go ahead.
Go ahead. Okay, good. Others?
Yes, sir.
Go ahead.
Perfect. That means you are able to relate. Chali, all right. So now let me copy this and instead of this parallel, oh sorry, peripheral. Yeah. So now you tell me. Yeah. So now you tell me. What about parallel protocols? Tell me.
AXI.
No. AXI is
On
parallel
chip.
type, but how or when you can say it's a parallel protocol? And then serial protocol.
Based on
Okay.
the
Point to
signals.
multipoint or multipoint to multipoint communication.
Yeah.
Point to multipoint or multipoint to multipoint communication.
Point to point. I'm sorry, I'm not able to relate.
The address are sent simultaneously.
Okay.
Based on
So
the signals.
good. Whatever you are saying, that's everything is correct. Now try to understand. I will give you 2-3 examples, and then you need to tell which one is serial and which one is parallel. Okay, let me take a small block. So here we have case A, B, and C and D. Perfect. So now try to understand. In this case 1, I am doing here address. I mean capital A is address. This is data. Okay. And this is response. Okay. And in another case, we have this TX and RX only. Okay. And here we have, oh, 1 second. So here we have, 1 second. Yeah. So TX plus TX minus RX plus RX minus, and here we have TX1, TX2, TX3, RX1, RX2, RX3. So A, B, C, D, which are parallel, which are serial?
A and D are parallel. B and C are serial.
What about others? Tell me. Tell me, guys. Which they are TX, RX, right? So which, or you can consider master slave, host device, whatever you want, you can consider. So I gave you 4 options, and I connected channels or interface. And my question is, which of them are belongs to parallel protocol? Which of them are belongs to serial? Or serial communication and parallel communication? Tell me. It's a very simple question. No response.
So parallel.
Parallel? Parallel, which option? You have to tell which option parallel.
A option.
Okay, A is parallel. What about BCD?
PCD is serial.
Okay, so she is saying only A is parallel. Now, someone said A and D are parallel.
ABD are parallel.
A, B, D are parallel. And C is serial. Okay, good. What about others? Interesting. Interesting. Tell me. So if you don't know what is the difference or for which you should say parallel or serial, then how you should learn a PCI protocol? So these starting sessions, for that only, you should have better understanding of this clock, this serial, parallel, what is the necessity of on-chip protocol, what is the necessity of peripheral protocols. Okay, then only you will be able to understand the PCI topology and those things and link. बहुत कुछ है. But these are basic questions, guys. Okay, let me talk like that. What about option A? Is this parallel or serial? Anji? No
Parallel.
response? Okay, parallel. How you are saying it's parallel? Tell me.
Here there are 3 signals A, D, R.
Okay.
And these signals are parallelly driving.
Okay.
That's why it was a parallel protocol. And
Okay. And what about option C?
option C, here TX1 and RX is there. These are the 2 signals, and TX plus and TX minus. these two are related. So this one is serial communication.
So you, 1 minute. You are saying address and data are not related, or you are saying if AW address, AW size, AW data, so they are not related. Those are
No,
also
sir.
related, right?
They are
What will be
related.
related? You should be on your words. So it's not. I mean, why I'm asking this question? I want to understand how you are categorized, and then I will tell you how actually you should categorize.
Actually, we can't categorize with this. There is no clock only, right?
Okay, clock, you can take assumption, whatever you want, because
Sir,
I'm
sir,
expecting. Yes. Okay, let me put
sir,
clock
I'm
here.
Sandhya. Like in my
Mm-hmm.
hello,
Yes.
can I tell?
Yeah, go ahead.
Yeah, like in my understanding, like first one is address, data, and response, which is related to AXI, and like B is transfer and receiver, like it is similar to UART, and C
Okay.
I don't know, and D is the there are multiple lanes, like it's like a PCM. Like I'm thinking that way.
No, you are thinking in a correct way, but what is the answer?
Like AXI is C parallel. B is a UART. UART is also serial. D is a PCI. It is also parallel. C, I don't know.
So this D is serial, you are saying.
So sorry, PCI. PCI is the parallel. No?
PCI की बात ही नहीं कर रहे हैं हम यहाँ पर.
Like,
I'm
in
talking.
my understanding,
Like she is assuming like
हाँ जी.
in my assumption, like PCI has multiple lanes, no? So here we have 3 transactions and 3 receivers. So it will like in parallel.
Okay, so this is parallel.
These.
Okay. Parallel. Okay. What about others? So it's a very interesting, right? It's a very simple question, but we are getting different answer. How interesting
Sir,
it is.
it depends how we are transferring our data. Suppose TX having the multiple bits in it, so it can be serial. But if this TX having only one data to transfer and RX on having only one data to respond, then it can be the parallel.
Okay. Okay. Yeah, it's different answer. Good. Good. So anyone want to explain like that?
So in first option, we are actually sending address data separately. So that is parallel. But in TX and RX, we are sending it as a packet. So that is serial. I am assuming like that. I mean, with respect to, I mean, in TX and RX, we send as a packet. No, in that packet itself, everything will be there.
बट पैकेट तो हम मतलब कहीं भी शेयर कर सकते हैं ना. ओके, लेट मी आल्सो टेल यू, व्हेन आई सेड एड्रेस, so this address may belongs to multiple signals also. It could be address space itself, right? Let's say AW size, AW LAN, AW address. Okay, those things. So how actually you should identify it's a serial protocol or it's a parallel protocol. क्या हमें सिर्फ ऐसे आइडेंटिफाई करना चाहिए, like he mentioned tx plus minus are related, hence I am saying, is it like that or how? Okay, now let me tell you.
these signals how they are behaving according to the clock.
No. So let's say, for example, I remove all these naming convention because this naming convention is just to confuse you. Let's say if I am putting small a, b, c, and here capital A, capital B, here capital A plus, capital A minus, here capital A, sorry, B plus, capital B minus, and here A1, A2, A3, and B1, B2, B3. Now what you will say? And on what basis you are saying they are related? And let's say instead of ABC plus minus, let's say if I am saying A, B, C, D, or let's say if I am doing X, Y, X, Y, Z, and P, Q, R, or let's say if I am saying S1, S2, S3. So This is not the appropriate way to identify either it's a parallel protocol or serial protocol. So now you might thinking, sir, then question itself is wrong. So it might wrong. Then you are taking assumptions like C took कि सर यहाँ पर TX1 TX2 दिख रहा है तो ये PCI लग रहा है, ये AXI लग रहा है, which is correct. But the intention of putting this question is that so that you should understand how to identify. It's not like कि अगर PCI है तो serial है, AXI है तो parallel है और हमें justify करना है. It's not like that. So now let me tell you, if you are having any TX, any RX, any TX and any RX, and you have any signal, forget about number of signals or name of signals, S1, S2, S3. You have one clock and forget about the clock is part of that channel or not. ये भी भूल जाइए. Now try to understand if at a single pauses or at one pauses, if you are transferring a single bit, and at next pauses, if you are transferring a single bit, this is nothing but a serial communication. क्योंकि serially bit by bit इसी का तो मतलब है ना serial. Now in the second case, if at single clock you are transferring multiple bits, that will become a parallel communication. Having said that, now I want to introduce something new here. Now try to understand. Let's say on this same clock, if you are putting these many bits, this is one case. Now I want to introduce a new case here. Let's say if you are having a one clock. Okay. Yeah. 1 second. And I am introducing, let's say 4 or 5 bits. So you know what's the difference in these two cases? So this will become parallel of serial, or you can say many serial communication. Now you will say, sir, then how I can identify between, मतलब ये कैसे पहचाने कि ये parallel communication है या multiple serial communication है? Yeah, I will tell you. If the reference clock is common, like if it's with respect to a single clock intentionally, and if they are having their own, there are multiple clocks, let's say C1, C2, C3, and let's say this is C1, let's say this is C2, and let's say this is C3, let's say this is C4. So if clock is different and each clock is having one bit per clock, then it will become a parallel of serial. That means many serial communication. But here we have single clock, and at the same clock we are transferring multiple bits. This is nothing but a parallel communication. Now let me put the example with respect to this. So parallel communication is perfectly a AMBA protocol. Let's say AXI, AHB, APB. So because there we have AW clock, मतलब right channel के लिए एक clock है, and we have to transfer AW address, AW bus, AW different thing. I mean, for a particular signal, for a particular clock, we are transferring multiple bits. Then this is nothing but a parallel protocol. But if you are transferring TX plus and TX minus and RX plus and RX minus, so what happens is, if you are transferring 4 signals, or if there are 4 different channels, so they don't have a single clock, they have their dedicated clock. We already discussed data pattern itself is containing clock. So they belongs to serial communication, but that doesn't mean multiple serial communications are not happening in parallel. मतलब ये 4 serial communication है parallel में. And if you have only TX pin, that is nothing but a serial communication, because 1 clock 1 bit, 4 clock 4 bit, and 1 clock 4 bit. So this is nothing but 1 clock at the rate 1 bit. This is 1 clock. This is 1 clock at the rate n bit, and this is n clock n bit. So if I will go to ABCD option, what was my intention? To tell you this only. You got my point, guys?
Yes, sir.
No response. So this is the third category which might confuse you. So as she mentioned, sir, यहाँ पर TX plus 1 2 3 4 हैं. So it leads to a parallel communication. Answer is no. So there are 4 serial communication is happening in parallel. It's like that. Clear? No response?
Yes, sir.
Yes. So anyone have any doubt now?
No.
So according to this, what will be option A, B, C, D? Option A will become parallel. Option B will become serial. Option D will become serial. Oh, sorry. Option C and D will become serial, but there are many serial communication is happening in parallel. Got it? No response? Why it is stuck? I want to show you that in PPT. Why it is stuck? I don't know. 1 second, guys. Can you hear me?
Yes, sir, we can. I understood.
1 second. Let me. Yeah. So now can you see my PPT?
No, sir.
No, sir, it's not sure.
Oh, 1 second. Let me share. So that's why when I put a definition, so what I said here. So what I said here. Yes. So if you are putting multiple signal, all signal means many signals are communicating concurrently with respect to single clock. Okay, so you can see AW burst, these are at 1 clock. So that's why they are referring to a parallel. So the same you should put here. So when you say it's a parallel protocol, so all signals, or if, 1 second. Yeah. So okay. So if many signals driven concurrently at same edge of clock, so we'll say this is nothing but a parallel protocol. Or let me put this here. Okay. And what happen if one signal or one bit, if one signal driven concurrently, no, not concurrently, at same clock as means at single at edge of clock, so that is nothing but a serial protocol. But if, I mean, should I write that point or not? So I mean there is a possibility in which you are having n signal might drive at n edge of clock. So that doesn't mean they will become a parallel protocol. So they will become a multiple serial communication or many. So it's like that. Make sense?
Yes.
So how you should identify? It is not like कि पैरेलल में 3-4 सिग्नल हैं तो पैरेलल है, एक है तो सिंगल है, सीरियल है. इट्स नॉट लाइक दैट. यू हैव टू अंडरस्टैंड द कॉन्सेप्ट कि एक क्लॉक पर 5 बिट जा रहे हैं, देन इट्स ए पैरेलल. एंड एक क्लॉक पर एक सिग्नल जा रहा है, देन इट्स ए सीरियल. और 5 क्लॉक पर 5 सिग्नल जा रहे हैं, इट्स ए आई मीन बंच ऑफ serial communication. It's a bundle of serial communication. That was the D case. In this, that was the D case. So this D case belongs to ये C तो मैंने ऐसे ही एडजस्ट किया था टू कंफ्यूज यू, बट मेन A, B और D हैं. So A is perfectly parallel, B is perfectly serial, and D is many serial. So don't confuse when D comes into picture. The concept is because a single bit is transferring dedicated to that clock. That's all from my side for today. So anyone have any doubt, you can ask, else we'll go ahead and we'll see tomorrow. Make sense?
Sir, can you give overview for today class? I joined late.
Sir,
An
one
overview?
minute.
Yeah.
In multiple serial in multiple serial communication,
Mhm.
like
See, there is
suppose
no category. Let me be very clear. There is no category. There is no category of multiple serial. There could be multiple parallel also. It's like that. So don't make any extra assumption or any overthink on that. There is only two category: parallel or serial. Multiple serial is also possible. I mean, many serial is also possible. Many parallel is also possible. But just looking into many serial, don't consider them as a parallel. That was my intention. There is only two category.
multiple serial communication means each bit will be at a different clock.
नहीं, उल्टा. For I mean, for at every pauses of clock, you are transferring only one bit. You have to say like that.
Yeah.
Got it?
Hmm.
For a single edge, you are transferring only one bit. You are not transferring multiple bits concurrently. But in parallel, for at the one edge itself, you are making sure you are transferring huge or bunch of bits. That will become a parallel. So there is no category for many parallel, many serial. It's just like if you are seeing many serial, don't consider them as a parallel. That was my intention. If you are catching T1, TX1, TX2, TX3, RX1, RX2, RX3, don't consider them as a parallel protocol or parallel communication. There are multiple serial communications are happening. So that was my intention. Clear, sir? Okay. Shall we close?
Sir,
Yes, sir.
overview can you give?
Sir, overview क्या हमने तो overview किया है. When you join? When
I
you
had
joined?
I had interview, sir, so I was doing that too.
No, I'm asking at what time you joined. थोड़ा आइडिया
Sir,
मिलेगा ना. अभी ज्वाइन किया है
sir,
क्या?
yes, sir, yes, sir.
अभी ज्वाइन किया है तो फिर ओवरव्यू कल करेंगे ना, फिर अदर्स का भी ओवरव्यू हो जाएगा.
Okay.
Yeah. So tomorrow when we will start the session, at that time you should ask. Then I will overview. So that others can also review. और बी के लिए जस्ट आपको बताना है तो बस यही बता सकता हूँ. वी हैव two types of protocol: on-chip protocol and peripheral protocol. So on-chip protocols are limited by, I mean, these are the advantage, these are the disadvantage. So they are limited by frequency and they are limited by skew. And that problem is resolved, or that problem is not there in the peripheral. So just because of the clock is embedded into data patterns, so there is no dedicated clock signal. Hence, there is no setup and hold violations. And later on, we just discussed how the parallel and serial protocol are differ. I think this you heard. So, or this one line is self-explanatory to understand this. And if you want, so maybe in the starting of tomorrow's session, it will be good if we are having review, so that
Yes, okay.
others can also relate or others can also enjoy. Not now.
Yes,
Clear?
okay, thanks. Yes, thanks, sir.
Okay. Thank you, guys. Thank you.
Thank
So
sir.
you
Good
are able
night.
to understand now. Now you are able to ramp up nicely. The
Okay.
flow and speed and everything, the face is fine. Okay, I will ask after one more two session. Thanks everyone. Thanks everyone. Bye. But let me very clear: if you missed even a single session, that entire protocol will become a horrible movie for you. So be careful about that, and you will be. I mean, only you will be responsible for that. If you are not available, ask to reschedule the session or ask to cancel the session for that particular day. But don't miss any session, else it will become a horrible movie for you. Thank you, everyone. Bye.